All right, let's dive in. Today, we're going to follow the journey of a modern engineer. And it's a wild ride, you know? It starts with the beautiful, clean logic of mathematics, but then it has to fight its way through the messy reality of educational systems just to get to the finish line, which is, of course, actually powering our world. So, I want to start with a question that really gets to the core of this whole thing. What does a beautiful, precise little formula from the world of physics like this one, what in the world does it have to do with the real-world headache of actually getting a qualification? Now, just so we're on the same page, this equation here describes how voltage works in an inductor. It's a cornerstone of electrical engineering. It's clean, it's predictable, it's basically a fundamental law of how the universe works. So how does that perfect, logical world of theory connect to, well, this? The complicated and, let's be honest, often super frustrating reality of human systems. And this quote, this really captures the tension, doesn't it? It's that massive gap between knowing the math inside and out and actually holding that diploma in your hand. So how on earth does an aspiring engineer get from one side to the other? Let's start at the beginning with what we could call the engineer's blueprint. This is the foundation, right? The promise of the whole field, where everything is built on a logical, predictable plan. And this image just perfectly captures the appeal of it all. I mean, it's a world built on absolute precision, where mathematical laws are in charge of everything. Every little piece has its place, and it all works exactly how you'd expect. And what's so cool is how calculus becomes the language for all of this work. It's not some abstract thing you just learn in a classroom. No, it's the actual tool set engineers use to describe and predict how things will act in the real world. And check this out, it breaks down so nicely. On one side, you've got integrals. Think of them as tools for summing things up, like how much total energy did this circuit use over an hour? Then on the other side, you have derivatives. They measure how things are changing in a single instant, like how fast is the current changing right now? They're really just two sides of the same incredibly powerful coin. Okay, so you've got this beautiful logical theory, but how does that turn into an actual formal education? Well, that brings us to what feels like an academic labyrinth, where that clean blueprint runs smack into the messy reality of schools and systems. In a place like South Africa, the path is often laid out by something called the National Qualifications Framework, or NQF. And as you can see, a student moves through these different levels, from N1 all the way up to an N6 diploma. On paper, it looks like a pretty clear step-by-step ladder. But yeah, that simple ladder, it pretty quickly explodes into this giant, complex maze. A student has to figure out which path to take through a whole universe of specializations: marine electrical, solar energy, digital electronics, you name it. Each one is its own little world. So, you're doing it. You've mastered the calculus. You're climbing that NQF ladder. But what happens when that logical, straightforward path collides head-on with illogical, human-run systems? Well, that's when you get a system short circuit. You get this: a single sentence and a notification that brings your entire life to a screeching halt. An alleged examination irregularity from months or maybe even years ago suddenly pops up and puts your whole future on hold. And here's the kicker: a lot of the time, the problem has nothing to do with the student. As this note says, it can be a technical problem with scripts. It's a systemic failure, a breakdown in the process of marking, recording, and checking a student's hard work. So what's the result of that systemic failure? 11 months. An almost year-long suspension while someone, somewhere, investigates. For a student just trying to get their career started, that is a devastating roadblock. We're talking lost time, lost opportunities, and just a massive amount of stress. And this is how a student gets trapped. They're sitting there, waiting for their results, but then the system says they failed to submit some information. While they're stuck in that limbo, the deadline to ask for a remark just sails on by. It's a classic bureaucratic catch-22. So when the main road is blocked by something you just can't move, what does a smart, modern learner do to keep going? Well, they rewired their whole career path. They pivot hard. Instead of just waiting around, they find new ways to learn and get their skills validated, turning to online courses and alternative credentials from institutions all over the globe. And just look at the new toolkit they're building. You see the shift, right? It's moving from pure electrical theory to these incredibly in-demand skills like data engineering and cybersecurity. This isn't just a plan B, it's a really strategic move toward where the entire industry is heading. Which, brings us to the biggest question of all. Why? Why go through the calculus, the exams, the bureaucratic nightmares? What is the ultimate point of all this effort? The whole journey starts here, with something that looks complex and abstract, like this differential equation for a robotic system. It's pure theory, just numbers and letters on a page. But this is the destination. The reason for learning all that math isn't just to pass a test. It's to solve real, profound human problems, like figuring out how to provide reliable and affordable electricity to communities that need it the most. This just sums up the whole story we've been telling, doesn't it? The complex theory is all in service of a real-world impact. The frustration with bureaucracy inspires a pivot, and that pivot builds a career that's defined not by a single piece of paper, but by resilience and a commitment to always keep learning. At the end of the day, this whole journey leaves us with a really big question. In a world where you can learn almost anything online, but the official credentials are still locked behind these slow-moving institutions, what does it even mean to be qualified? Maybe the most important skill for a modern engineer isn't just mastering calculus, but learning how to engineer your way through the system itself.